in many areas of our life, we would be interested to know whether there is a correlation between the two things. For example, I would be interested to know how the car weight affects to the gas consumption, or how the number of the absent lectures affect the grade. So if I have the data for both of these two cases, one of the ways to understand the correlation between these two things would be just make a line which is passing through all of these points. Obviously, we cannot do this, but what we can do is we can create a line which is going to pass through all of these points in a way so that the total distance from all the points to this line is going to be minimum. Or we can do this thing to here for this data set, and this line is going to be called the regression line. Or in calculus or in linear algebra, this is called the least squares approximation. So let's discuss how we can do this. So we are going to take the 3 points, and I would like to make the line passing through all of the 3 points. The equation of the line can be written as kx plus b, where k is the slope of the line and b is the y-intercept. So depending on these 2 parameters, I can create the line. So basically, I would like to find which 2 parameters I need to choose so that this line is going to fit to my data in the best way. So I will assume that I'm going to pass through all of the 3 points so that I can if I substitute the coordinates of the points to the equation, it is going to be true for all of these points. So let's do this. It's going to be 0 is equal to the 5k plus b. 0 is equal to the 3k plus b, and 2 is equal to the 0 multiplied to the k plus b. So by solving the system, we can find the k and b. So at the same time, we can write down the system in a matrix form. It is going to be 5, 1, 3, 1, 0, 1 multiplied to the k and b, and this is equal to 0, 0, 2. So basically, we wrote down the system in a matrix form as AX is equal to the B. So the solution for the system is going to give us the 2 parameters of the regression line. So the problem is the system has no solution, right? So we know that we cannot make the line which is going to pass through the 3 points. Or we can see this from the augmented matrix of this system as well. So what we can do is we can discuss this a little bit further. What does it mean that the system has no solution? So when the matrix comes with the 2 columns, the column space of the matrix is going to be the plane. So basically, all possible linear combinations of the columns of the matrix A is the plane. So basically, this plane is explained as the first column and the second column of this matrix. So basically, all possible linear combinations of these 2 columns is going to be this plane. And we can find, so solving this system of linear equations basically means, so if you have some point on this plane, so which combination of these 2 columns is going to give you this vector b, right? So if this vector b is on this plane, right, is some vector b prime, let's say, you can find this by combining the 2 columns of the matrix A, so the column 1 and column 2, which are on the plane. But the problem is this vector b is outside this plane. So that is why the system has no solution. So the no combination of these 2 basis vectors, c1 and c2, is going to give you a vector which is out of this plane. So that is why the system has no solution. So what we would like to do is we can solve the system only in a case if this right-hand side part is on this plane. So I can solve this system approximately by choosing some vector from the plane and substituting this with the original b. So what does it mean? That I need to choose such a vector b or some p from this plane so that it is the distance between this plane and this vector, it's going to be a minimum. Right? So basically, the distance between the point and the plane is minimum where I make the perpendicular to this, right? So if this is perpendicular, this is going to be, this vector is going to be the projection vector P. So basically, I need to find such a combination of the columns of the matrix A so that this is going to be equal to the projection vector. So I can find this x using by solving the system. A transpose to the A x hat is equal to the A transpose to the B. So this x hat is going to be the vector which gives us the projection. So basically, if I find the x from here and if I substitute it to here, it is going to give me the projection vector. So please note that we're not interested to find the projection vector. So we're interested to find such a combination of the columns of the A which gives us the projection. So we can do this for this example. So let's say A vector, A matrix is given as 5, 1, 3, 1, 0, 2, 0, 1, sorry. And the B vector is given as 0, 0, 2. Right? So let's solve the system. A transpose to the AX hat is equal to the A transpose to the B. So please note that I'm denoting this as X hat because this is different from this X. So we can find this X, but what we can do is we can find the approximation for this X, right? And this approximation is going to be the best because we're choosing the vector from the plane which is the closest to this vector B. So the A transpose to the A is equal to the 5, 1, 3, 1, 0, 1, which is multiplied to the 5, 1, 3, 1, 0, 1. If we multiply this is going to be the first row multiplied to the first column. It's going to be 34. If you multiply the first row to the second column, it's going to be 8. Then this is 8 and 3. So if we multiply the A transpose to the B, what we obtain is 5, 1, 3, 1, 0, 1, which is multiplied to the 0, 0, 2. It means that you can multiply the first row to the first column. That is going to be simply 0. If you multiply the second row to the second column, you'll obtain the 2. So basically what we need to do is we need to solve the system. 34, 8, 8, 3, multiplied to the x hat, which means that it's going to have the two components, k hat and v hat, is equal to 0 and 2. So we can solve the system, and what we obtain is, so we can solve the system using the augmented matrix. It's going to be 34, 8, 0, 8, 3, 2. So we need to eliminate this entry. In order to do this, we multiply the first row to the minus 8 divided to the 34, and we add this to the second, and we obtain is 34, 8, and 0. And here we obtain 0 minus 64 divided to the 3 minus 64 divided to the 34 and 2. So we can find the solution for the system already from here. So which is going to be 102 minus 64 divided to the 34 multiplied to the b hat is equal to the 2. From here we obtain that the b hat is equal to the 34 divided, so the difference is 38 divided to the 19. So we can find the k hat from the first equation. The first equation tells you that 34 k hat plus 8 multiplied to the b hat is equal to the 0. If we substitute the b hat to here, it's going to be 34 k hat is equal to minus 8 multiplied to the 34 divided to the 19. Right? So we can cancel the 34 and 34. And what we obtain for the k hat, it's going to be minus 8 divided to the 19. So the equation of the line, which is going to pass through the 3 points in the best way, is going to be minus 8 divided to the 19x plus 34 divided to the 19. So this is going to be the least square approximation for this system of linear equations.